11 degrees below zero right now in Chicago. And take a look behind me. You can see the vapor rising from Lake Michigan here. It's that cold. And overnight, we got new video showing just how cold it is here in the Midwest. Take a look.
My name is Dave Black. I'm a faculty member in the School of Marine and Atmospheric Sciences, and I study climate change, in particular past climate change. And there are these really fast-moving bands of air, just high-speed wind, that sit at the edges of some of the large-scale atmospheric circulation cells. The polar vortex isn't a fixed phenomenon. It can migrate, just like any stream of water can move, so can the stream of air, and periodically it does migrate, and that's something we've experienced a little bit this winter. In terms of the warming that's occurred over the last 150 years or so is the rise in greenhouse gases in the atmosphere.
The change is, that's happened in the past 100 years is about 1 degree Celsius. Pretty small change, but the point here is that these changes are significant, and as we look further in time, those changes may be intensified in their future growth, and that changes our circulations and changes our weather patterns and results in changing our climate.
Roughly 97 and 90% of scientists who this is their field agree that humans are unquestionably contributing to climate change and have been for at least the last century and a half. We can debate how fast the response is, we can debate the magnitude of the response, but the question of whether or not humans are impacting climate within the scientific community is dead. I mean, that was decided a long time ago. It is possible to relate the jet stream and the polar vortex to climate change. One of the things that keeps the polar vortex up around the pole is the strength of the subpolar jet. It essentially acts as a fence. The strength of that jet is determined by the temperature gradient between lower latitudes and higher latitudes. The stronger that gradient, the stronger the wind, and essentially the stronger that fence is. The weaker the gradient, the jet stream weakens, the fence becomes weaker, and that makes it easier for the polar vortex to slip towards the equator. It's actually not the polar vortex itself that we worry about at the surface, but it's the really chilling Arctic air associated with it at the surface. As the Arctic heats up faster than the tropics do, you decrease that temperature gradient, you weaken the subpolar jet stream, and that makes it easier for the polar vortex and its really, really cold surface temperatures to extend further south. As the Arctic continues to warm, and we're expecting it to warm, worst case scenario, it has it warming by as much as 8 degrees Celsius by the end of this century. That's as large a change as the average global temperature change between an ice age and today, so it's a staggering amount of warming. Even though that's going to substantially weaken the jet stream and allow polar conditions to extend south further than they have in the past. Climate change does appear to be doing to weather is it increases the likelihood of extreme events. It's sort of like loading dice. You weigh one side of the dice and it makes it more likely for the other side to come up. Or you could say it's like painting an extra dot on the dice. Sometimes you're on average still going to roll a 7 or an 8, but occasionally you might hit a 13 that you wouldn't have otherwise. It wouldn't surprise me at all if we see it more commonly.
We can expect, as a result of global warming, to see more of this pattern of extreme cold in the mid-latitudes and some extreme warm in the far north.